Okay, so hi. Good afternoon. Thanks for coming to, is this the second to last session, I think, of the whole conference? So I appreciate you guys hanging in there. So my name is Brian Benz. Benz on Twitter if you want to follow along and live tweet or follow me, follow you back. And today I'm going to talk about how to deliver your Java code to the cloud. I'm a cloud developer advocate at Microsoft, and it's my job to tell people about our cloud, Azure, but also get feedback from the community about what we should be doing, what we're doing right, what we can do better, things like that. So the things I'm going to show you today are all open source. They're all on GitHub, and you could use them with any cloud, the same techniques, same ideas, but I'll be showing Azure. We have some plugins for Eclipse and things as well that I'll show too. So I'm going to talk about platform and deployment options, VMs, containers, and software as a service. And I'm going to also talk about some of our SDKs and tools that we built to make things a little easier for people, and then a few other resources we have, and then Q&A. So how many people here use containers right now? Okay, actually, yeah, that's like 20%. That's good. And are you using orchestration like Kubernetes, things like that? Okay, one person. Okay, cool. So containers, standalone, I guess. How many people are using containers in production? Okay, 5. Okay, cool. Well, basically, what I'm going to talk about today is the different ways you can get your code on Azure, including containers. I just want to get a little bit of a feel for the audience to decide if I should show VMs or containers. I think I'll go with VMs for the demo for the first one, and I'll show you how to do it with different things, including the command line and some portal options as well. So we have a portal on Azure. How many people have used the Azure portal before? Just a few. Okay. So I'll show a little bit about that. How many people have used a CLI? Not the Azure CLI, but any CLI. Okay. Everybody. Yeah. So basically, we have a portal that we use at Microsoft to do a lot of things. We also have a very extensive CLI and some really cool things about that CLI I'll show you. And then we have templates, these things called ARM templates that we use, which are JSON-based orchestration tools that we've built that you can use to deploy things to the cloud. So let's start with the portal. So here's our portal. This is my portal that I use all the time. Whoops, what happened there? And basically, each one of these little tiles here represents something that I've been working with. We have web apps and other kinds of tools, and all kinds of stuff there. Let's see here. I don't know what just happened there. I am done customizing. If you want to create something in Java, basically you go to create a resource, and this takes you to everything that you can do with Java. You can just do a search here. So we have several things sort of out of the box you can use. We have this thing called Java Coffee Shop, which is a little WAR file. You can put it in our software as a service, and it runs. We have all kinds of VM templates that we've created in conjunction with Bitnami. Here's a JRuby, for example. This is a VM. It's running on Ubuntu 14.04. It's got Tomcat, MySQL, and a few things to run JRuby already made. So if you have a JRuby environment, you want to get up and running quickly, you just click on this. By the way, 40% of our VMs on Azure are actually running Linux, which is a big news. I was talking to some people at Java 1, and they were saying, is this a trick at Microsoft? Are you guys just building up this Linux thing, and you're going to do something to harm it? And no, we're not, because it's a big part of our business. It's the fastest growing part of our business. So we're not going to do anything with Linux except contribute to it and help in its success. So, anyway, we've got Tomcat images that we use. This is another web app, and I'll show you what these web apps are later. We have a partnership with Azure. Azure Zulu has a pre-made VM with Azure Zulu on it and a few other tools to get you started quickly. We have WebSphere. We have WebLogic. We have all kinds of other things. Pivotal Cloud Foundry. We've worked with a lot of different partners to put pre-made VMs on Azure. What if you don't want to work with a pre-made VM? You can actually build your own VM using Hyper-V. I'll go back to that in a second. So the Hyper-V option is basically you build your own VHD file, virtual hard disk file. You put things onto it, and you can put it on storage. You can have it locally, and you can deploy that out to Azure just like you can with these other pre-made images. But the thing I want to show you today is really the Azure CLI. It runs on Windows, Mac, and Linux. It's Bash compatible, and it's extensible. It's written in Python. So if you have something you don't like about it, and you have some Python developers or some Python skills, you can actually extend it. We have ways to do that. The other cool thing, so I've got a Windows machine. I can run this Azure CLI from the command window. That's no big surprise. So AZ is how I do that. There's all the Azure commands. So the CLI itself has got a bunch of pre-made things. So for example, you can, if you already invested a lot in Bash scripts, you can use those Bash scripts to deploy to Azure. You just have to add an Azure CLI portion that creates a virtual machine and that deploys things out to that virtual machine, just like you would a regular machine that you have on premise or a virtual machine you have on premise. And then we also have Bash on Windows. So Bash on Windows is a fully functional Bash environment. It's written in conjunction with Ubuntu, so it's an Ubuntu environment. And it basically has everything you would expect from Ubuntu built in there. And once again, you got the Azure CLI. But the coolest thing, so there's that there. The coolest thing, let me get back to the portal here. We also have the CLI built into the portal. So any web browser you go to, you don't have to install anything. The CLI is actually built into the portal, and that's what that little icon up there with the arrow, I've hit that, and what we're doing is we're creating a container on the web, and that container contains not only the Azure CLI, but a bunch of other pretty cool things. Once it gets going, connecting terminal, and it also logs into my account. So if I'm using a local machine, I have to log into my Azure account, so it knows where to put VMs and networks and things like that. But if it's on the portal like this, so it's just created a container. It's got my CLI here, so I can do that. I can also, if I want to work with Kubernetes, kube controls on there. How many people are working with Cloud Foundry by any chance? Nobody. Okay, never mind. Oh, it does have Cloud Foundry too, if you ever choose to do that. And we have a bunch of, the point is we have a bunch of different commands built in here. So you don't actually need to have a machine that you're actually running. And I was going to show it, but we don't have a way to switch. There's a app for iPhone and Android that has the shells built into it as well. So I could actually create a whole network of VMs and scale them out from my phone on a plane as long as I have internet access. The way I do it, I've got a bunch of scripts that I put in a file storage, and I just grab them off the web and run them like that. So it's pretty cool. So you can do a lot of things here. The two things you can't do from this portal is you don't have access to your local machine. You do have access to your local machine with the Windows subsystem for Linux or Bash on Windows, because you can mount from your local file system. Same with Mac or Linux. You can do that. You can't also SSH into things. So, all right, enough talk. Brian, let's show a demo, I think. Oh, so I showed you a little bit of the marketplace. You can get those community images from Bitnami, and you can create your own virtual hard drive as well, the VHD files. So I'm going to talk a little bit about VMs. Virtual machines, we have virtual machine scale sets that you can use. And what those are is you can have up to 1,000 virtual machines running Ubuntu or Windows or actually your Linux flavor of choice. We have Red Hat, SUSE, and all the major flavors of Linux. But the virtual machine scale sets are kind of cool because you can actually build them, scale them up, scale them down. Here's a CLI command for creating 1,000 virtual machines using the Azure CLI and putting them into a virtual machine scale set and having them access using a load balancer and having a subnet prefix you can use for all of them. That's all there is to it. You just create it. Whenever you create something on the CLI, you use a group, and you have to group things together. So my resource group, it's called a resource group. And then you create the name of the cluster that you're building. You can select a specific image, and I'll show you a demo of an image I'm using later. And then you can say how many counts for that VM scale set, and do I want a load balancer, and what do I want for a subnet prefix. And that's basically all there is to it. Once you've got that created, you can actually set up some rules. So if you want to create all 1,000 VMs at once in your scale set, you can start with 1 or 10. And basically, you have some rules you can set. You can auto-scale the minimum number of VMs. So let's start with in this case, we're going to have a minimum of 1 and maximum of 10. If the CPU percentage goes over 75%, add another VM with my code on it, everything ready to go. It's just going to add another one to the scale set. And then if that VM is not busy, if it goes down less than 25% CPU, kill it, bring it back down, and you can control a lot of different settings there, including the min, max, how many you want to increase by, how many you want to decrease by, the percentage, things like that. There's also more complicated ways to set these up. If you want to have a lot more VMs on Mondays, because you know you have a lot more traffic on Mondays, for example, you can set things like that up as well. One other thing I want to show you about the demo I'm going to show you in a minute. We have MySQL services and Postgres services that we've brought very recently. So if you have MySQL, you're using, how many people are using MySQL on the back end for Java? Okay, yeah, usually it's pretty prevalent, more than that actually. Or Postgres. Anybody using Postgres? Okay, a couple more. Yeah, so we have services you can use on the back end for that. So the demo I'm going to show you today is deploying a VM using just a single VM, really simple one. Let's see. So I've got an app. It's a Spring Boot to-do app that I've got on GitHub. And it's just a really simple to-do app. It runs locally, and it uses MySQL locally. So the first thing I have to do is, and I'm going to simulate some of this just for time, but I'll move into actually deploying to the app in a minute. So basically what I would do is set this up, run it locally, make sure it works, and it's a Maven package, so I just say Maven package Spring Boot run. And to build the package itself, you say Maven package, that will actually compile it. And then to run the app, it's Java jar, and you just run the war that you've generated with the Maven package file. And then I would go into the CLI. Now I'm ready to deploy this out to the cloud. Go into the CLI, create a resource group. That's the first thing you have to do with anything with Azure. Create this resource group, and then the command for actually creating the VM is here. azvm create, and the name of the VM that I'm going to create, and then resource group it's in, and then the location. So we have a ton of locations. I have 43 locations you can use for this. And then this is a key piece, generate SSH key. So it will automatically, when it creates the VM, generate an SSH key and place it on my local machine so I can securely connect out to that without anyone else hacking it. And I'm going to use a very specific image. So I don't have to, but we have a bunch of images built into Azure that you can use. In this case, it's Canonical's Ubuntu Server 1604, and it's the 2017-02 version, because I know that works for sure with my code. But you can also say latest or different things with Ubuntu as well. And then I'd get basically a response that tell me where the SSH public key is. Next thing I have to do is open port 8080 on that VM. So I would say azvm open port with the name of the VM and open it there. And then I get the IP address for that. And then the next thing I do, let's actually go in and do this. They're using Bash and Windows. There we are. So then I would just SSH into this. Now I'm in there, and I can just do a ls, and it shows me what we've got. There's the name of the war file, and then I just run the jar file. Well, first thing I did actually before I did this, I ran an update, and I installed OpenJDK using apt-get, and then you list the file. Oh, I did a list of the files, and I did a secure copy. Sorry, I'm skipping steps here. I did a secure copy to actually get that file up there. And that works without logging in because I have a SSH secure certificate on my local machine. And then I run the Java file. And it's a Spring Boot, as I mentioned, so it takes a second to fire up. How many people use Spring Boot or Spring applications? Okay, just a few. All right. It's definitely a very cool way to get up and running quickly with some apps. Let's see here. The next thing I can do is I can just open that app using port 8080. There it is. So the to-do list is there, and I can update a task, a demo. Let's see. At and add a task. That's it. So demo to Øredev, so it's there. I can delete it. I can mark it as complete. Whatever I want to do. It's just a silly little app to show how you can do things. But basically, that's all that needs to be done. So all I had to do was, create the VM, SSH into it, do a secure copy of the WAR file, or you could do a jar or grab something from GitHub and compile it using Maven in place on the actual VM. And then log into that file, run the Java command, fire up the app, and start working with it. And of course, as soon as if I could also use tmux, I didn't use tmux here, so as soon as I shut this down, the app is dead. So, but if I use tmax or some other tool like that, it'll actually run so that it'll keep going even after I log off the machine or shut it down or start doing other things on it. Yeah, so that's basically basically the dead simple version of deploying a VM, deploying an app to a virtual machine on the cloud. And as I mentioned, you could do that with scale sets as well. So you could actually add a very large scale set, 1,000 VMs if you have it for your app, and much more complicated setups. But that's just the bare bones. I didn't use any third-party tools or anything. I used Maven, I used the VM, and SSH and SCP to get it out there. So, so the other thing we have, for those of you using containers, we have a bunch of different options. We have Container Service, which is open source as well. It's Docker, and it uses DCOS, Kubernetes, Swarm, all the orchestration tools that you're used to using or that you want to use in the future. We also have this thing called Service Fabric, which is a microservices platform. It's sort of a managed, even though Kubernetes will manage your containers, this is a management of Kubernetes managing your containers, if you will. It's a way to actually manage multiple different container instances inside the same tools. And then we have options for doing single container apps as well. You can just deploy out to Docker. We have this thing called Azure Container Instances, which is build by the minute. You can create instances and shut them down. It's great for test and for using things. Service Fabric I'm going to skip over because a lot of people are using non-container apps, it sounds like, in this group. But Azure App Service I want to talk about as well. So I showed you VMs. That's at one end of the spectrum. You control the VM, Linux or Windows. You control the operating system, everything there. You have to do your own updates and things. On the other end of the spectrum is our Azure App Service. It's container-based. We manage the operating system that the containers run on underneath. We have Ubuntu and Ubuntu Linux and Windows options for the containers, and you auto-scale those. So let me show you a little bit about that. You can use .NET, Java, Node, Python, PHP. We have SDKs for all of these. It has auto patching, auto scale. So if there's a major security update that needs to be done for Ubuntu, we're going to do that for you. Same with Windows. And you can integrate with apps on the back end, and you can use continuous deployment. Oh, you know what? One thing I didn't show you, and it's relevant to this demo as well. The service on the back end for Azure. Let's see here. So I told you that the database works with MySQL. I skipped over that part for the to-do app. It's actually using an app over here, BB MySQL Demo. So BB MySQL Demo is MySQL service and all I had to do was set up in connection properties. I go in there and I just change the connection string in my app to point to my new service here, and that's how I actually get to the service that I'm using. Let me just shut this down so you can see it more. And yeah, I have several databases on here, and it's scalable as well. So that's one thing I want to tell you before we go into the next part, was we have that app that's running on Azure that actually uses, it's what's used for the database in the back end. So Azure App Service on Linux. Let's just go ahead to the portal and create one. You can do this in the CLI as well. It's just nice and visual here. So I can say create a resource, and I go to web and mobile, and I say web app for containers. And so what I'm going to do here is create a container app with a piece of code that's running on it, and you can deploy that out to Azure. Let's see, we'll call this one Øredev. Let's see. And I can configure the container here. Now there's 3 ways you can go and get your container. So basically the idea here, the theory is you've got your container ready to build. You've probably already tried it out locally. And now you want to put it on the cloud. Maybe share it with other people, things like that. There's 3 ways to do that. When you configure a container here, you can go into what we call Azure Container Registry. So we have a registry that you can use. It's a private registry that's already pre-built, and you can put your containers on there. And when you're ready, you deploy them out from here. So the idea here is you would go out. I've got a couple of registries set up. Here's my Azure Container Registry. And then I can go and grab an image from there. There's one. It automatically names them. And then you have to use a unique tag for each one, and then there's maybe a startup file for the container. So you can go there, or you can go to Docker Hub. And in Docker Hub, you can grab a Tomcat image, Jetty image, a bunch of standard images that are out there. Or if you have your own private registry, not the Azure Container Registry, but your own private registry that's not on Azure maybe on-prem, and it's accessible via URL, you can use that, and you can say my Tomcat, and then you actually put the server URL for your container registry and the username and password and startup file, and you can fire it up that way. I've got a couple already created, but basically what this would do when I create it, it takes a couple of minutes. It would run, it would create an image for me out on the web. Actually, let's just do this from here, Docker Hub, and let's go for Jetty. So it's going to go out and it's going to create a Jetty container based on the latest image from the Docker Hub. And I'll say pin to dashboard, say create. And that's all there was to it. So I showed you all the different options, but most of the time, if that's all you want to do, it takes a couple of seconds to just go out, grab the hub image, and deploy it. So it's deployment in progress. We'll come back to that. So that's App Server on Linux. The App Server on Windows is actually even easier because you just deploy it from our Windows infrastructure. So what else can you do with apps? So once you have your app, you've deployed it out to the cloud, you've got it on a web app. I'm going to show an Eclipse plugin in a minute, but once you've got your app out there and it's running, what I find most people want to do is they want to do sort of a lift and shift where they want to take their Tomcat app, put it on a VM, then they want to take their MySQL backend or whatever backend they're using, put that on a VM, connect them together, and then just prove that you can actually get it running on Azure or on the cloud. The next thing you can do is you can start using some of our services. I showed you the MySQL service and the Postgres service that we have on the back end, and all you have to do to change those from a VM running MySQL is change the connection string that you get provided in the portal. So inside the portal there, you'll get a little connection string. You change that connection string in your application, and that's going to point to the new instance of MySQL. The app won't know that it's running on a managed version on a cloud now. As far as it knows, it's still just connecting to a MySQL database. We also have other things. We have storage, of course, blob storage. We have Key Vault for managing secrets and things like that. SQL database, of course. Not only MySQL and Postgres, but we also have Microsoft's SQL Server. We have Data Lake, which is Hadoop, Spark, and a few other things built in. It's a big data option that you can use. We have Service Bus, Active Directory. Most large enterprises use Active Directory at some level for authentication. Application Insights is it's a analytics and telemetry tool that you can use. You get an instrumentation key when you sign up for the service, and it's free up to a certain point. You take that instrumentation key and you drop it into the web apps folder of your Tomcat or whatever apps server you're using, and you automatically start to collect telemetry. You can also add breakpoints in your app, and all that goes into a dashboard that's custom created for you automatically. You don't actually need to create it. And then we have Cosmos DB, which is our MongoDB compatible, what we call a multi-model database, and I'll get into that in a bit. And then we have web apps, which is what I showed you earlier with the containers. How many people are using Eclipse here? Okay, quite a few. How about IntelliJ? Everybody else, okay. It's never both. How many people are using both? A couple, okay. Yeah, well, there's some companies that you have to use Eclipse for certain things, and then other people, you know, and then when they're using it for themselves, they tend to use IntelliJ. But yeah, I'm going to show a demo of an Eclipse, but the functionality I'm going to show is exactly the same on IntelliJ. So let's go into Eclipse. Whoops. So Eclipse, we've created plugins. We have a couple of plugins for Eclipse, IntelliJ, and a few other things. Let's see here. And these are designed to make it easier for you to deploy things from Eclipse. So you don't have to leave and do all this CLI stuff that I showed you. You can, but you don't have to. So I mentioned Application Insights. We have a way to configure Application Insights inside your Eclipse plugin. You could say add Docker support, and that signs you up to a Docker registry that you can use to actually grab your images to deploy out to the cloud. You can publish your web apps as a Docker container or as an Azure web app. So a Docker container would be you have a VM ready and you just place it onto the VM. And the Azure web app is going to be a web app for Linux, and it automatically deploys it. So let's see here. I will use the Azure web app today. So what I've done is I've got just a standard Eclipse web project, and like I say, the functionality for this is exactly the same in IntelliJ. Same right click, everything. But basically it's just a simple little Eclipse project, and if I click here, it should just say hello. Yes. Okay. Now, what I'm going to do is I'll just say hello. Oh, and I know I'm spelling that wrong. There's an umlaut on the A, right? Is that right? Malmo? On the O, thank you, sorry. Does anyone know the ASCII code for that? I can't even remember what it is. I'll leave it like that for now, sorry. Anyway, so that's basically, I'm just going to update that a little bit. I'm going to save it. Now, to actually deploy this out to the cloud, all I have to do is do a right click and then say Azure, publish as Azure web app. And I already signed in. That's the only hard part. Just before we started, I signed into Azure with my account so that it has all these web apps sitting here ready to go. When I click on this one, this is the one I want to deploy to. It's just a Windows app, and down here you'll see the green bar. So it's deploying the web app. It'll come back eventually and show us the app. When you get a little published link there, then it opens up. It's taking a little longer than I hoped, so I'll continue on. I'll come back to this. But basically, that's the whole idea. It's really easy from Eclipse or IntelliJ to just deploy out to a web app or a container. Container is essentially the same. You just have to set up your VM first and then deploy out to the container. So it's a nice way to do things. You can also set up profiles inside of Eclipse. So you can say, when I deploy this, it's going to deploy with this image. If you don't have one already created for the web app, in my case I do. And in most cases you're going to set up that web app or that container infrastructure once, and then you're going to be iteratively deploying to that all the time. So let's check and see. Did it get done? Nope, not yet. Okay, so I'll talk a little bit about some other things we have. So we have multi-model, multi-API database. What's a multi-model database? It's called Cosmos DB. Well, basically, the multi-model is you can use key values. We can use documents. You can use columns, which are kind of like tables, but they're schemaless. So you can add a column and delete a column from the rows, and the database doesn't object. And then you can use graphs. And these are the APIs we have now. So if you have a MongoDB database, how many people are using MongoDB actually? A couple? Okay. So if you have a MongoDB database, you want to move to a managed service, you can do that through our application. Just change the connection string, once again, similar to MySQL, and it's going to point to a MongoDB instance. It's 100% compatible. It doesn't do a few things like map reduce and a few other specialized things, but for most MongoDB applications, it works fine. We have table storage API, Gremlin Graph, and Spark as well. All right, let's go back and see if that's done. No? Okay, I'll come back to that. I don't know why it's taking so long today. So we have the advantage of using Cosmos DB. It's managed. We have all kinds of latency and throughput guarantees and data consistency guarantees as well. Jet uses it. How many people know Jet.com here? That's probably more of a North American thing. Okay, a few people. Cool. Well, Jet.com is, I think they're owned by Walmart fully now. They run 100 trillion transactions per day on our Cosmos DB. We actually built Cosmos DB to run OneNote. If anyone's used Microsoft OneNote before, it's sort of something we use for managing, non-structured data. But we used it for that. We moved on. We've built a pretty cool multimodal database with that too. Azure Functions. How many people are using Lambda? Any kind of Lambda functions? AWS Lambda or, okay. So we have functions as well. They are compatible in most cases. So the idea behind functions, just for those of you who may not know, is, for example, you can set up something on the cloud that when you put a picture into file storage, it will automatically trigger an event, basically, that will go out, take that picture, and make a bunch of thumbnails of that picture, and then put them into another piece of the storage so you can use them in web apps and things like that. Now, that piece of code is basically, they call it serverless. It's also kind of codeless. You can trigger that code by Java, .NET, PHP, Python, et cetera, but it's not actually written in that code. So the nice thing is if you have a Java app that you want to do that with, you can use this function. If you have a .NET app or a PHP or a Python app, you can use the same function, all those different languages, just to trigger the app and have it run, which is a common scenario in the cloud. So that's the idea of Azure Functions. That's a very simple example. We also have Service Bus and several other things you can do. But we have Java support via, just realized support is misspelled on there, SDK with VS Code. And some of the things you can do to execute those is HTTP request, a timer, so at midnight every day, or every hour, do some cleanup on something. Storage change, so that's the one I mentioned, was something happens to your storage file. You add a picture, an IoT event, a record update, a tweet on Twitter. You can trigger something if a tweet comes up that matches a certain criteria. And the way that works is you have the trigger, then you have the input binding. You actually develop the code that's built in there in between. You execute that code. You have an output binding, which actually preserves any output from there. And you can use CI/CD, Jenkins. How many people use Jenkins here, by the way? Okay, quite a few. Good. And you can develop them locally on Visual Studio Code. I don't know if you guys have seen Visual Studio Code. This is it here. It's VS Code, actually. I like to call it VS Code instead of Visual Studio Code. It's an open source text editor. And you can use this for building your Java functions, because we have a Java SDK that's fully supported here. So you can test it locally and then deploy it out to Azure from here. And actually, we have a new feature that is it just came out today, where you can run those shell scripts, those ones I showed you on the portal, in a very similar way directly from here as well. So you can actually build your Java functions, your Java-based functions here, test them, and then deploy them directly from here without ever leaving this IDE. It also works with Eclipse and IntelliJ as well. So that's another piece. DevOps. CI/CD, telemetry, analytics. Actually, before I move there, let's go back here. There we go. So it is published now. So hello Malmo. It's working now. So basically all it does is, like I say, you right click, you say publish, and then it's usually a lot faster than that, but as soon as it says published here, you can test it and make sure it works. It's great for iterative development in Java. So getting back, DevOps. So we have CI, CD, telemetry, and analytics tools you can use. How many people here have heard of Visual Studio Team Services? Just a couple. Okay, that's actually more than normal. In the Java world, it's not well known, but it is pretty cool. We have Jenkins plugins for it. It's actually it's a build management tool, but it's more of a project management tool. It's based on what we call Team Foundation Server. And the idea here is if you have multi-code projects, so you have a project that has a Java part and you have a project that the same project has .NET or Python or PHP, you can actually manage all the code from those. Developers can check out and check in, and when they do that, it will trigger a Jenkins task, and that Jenkins task will actually go out and run things locally on Azure, wherever you want it to be, any cloud actually. We have built Azure Storage and ACS plugins for this. Let me see here. Azure. Microsoft Docs. So we have a site here, Jenkins on Azure. We have CI that you can use with the app service, Kubernetes, or Linux VM. And where are the plugins? Yeah, here we go. Let me just open these up. A few other things. So Azure VM agents. So the idea here is with Jenkins, you can have a master process that calls a bunch of agent processes. With this plugin on Jenkins, you can actually create agents, actually VMs that will host your agents. So the virtual machine will actually host your agents for you. And the idea here is that you have one master task and then you have 60 different agent tasks that are going to run and report back to the master task when they're done. And these could be tests or deployments or whatever you want them to be. These can be virtual machines. They can also be containers on Azure. And they can be configured very easily, built into Jenkins actually. The part of it that you want to use once you add the plugin, there's a little section down there, use this VM image and start it up, and then you can actually put them to sleep or shut them down completely depending on if you need them often. If you need them often, you can just put them into a dormant mode so they're there and running and ready to go the next time you need them. But if you want to save money, you delete them and you're not using them. And then we have a Jenkins Azure App Service. You can actually use, you can deploy from Jenkins to an Azure App Service. And the other one we have is you can deploy directly out to storage as well. Let me see here. Yeah, Azure Storage. I thought I clicked on that. So the Azure Storage plugin just simply allows you to deploy artifacts out to Azure Storage from Jenkins. And I mentioned before we have App Insights for Java. App Insights itself is a tool that you would use to create telemetry. You can put an instrumentation key that Azure provides onto your app, and then that instrumentation key will write telemetry data to a customized dashboard for you. Oh, cognitive services. How many people are using some kind of machine learning or cognitive services? Something like that? Okay, cool. I've got a fun demo to show you. A colleague of mine actually created this thing called Bacon Not Bacon. How many people are familiar with Silicon Valley? The show Silicon Valley. Sorry, not the actual place. Okay. Yeah, let me see. I'll show you. This is kind of fun. So we have, this is actually a fun demo for a serious thing. So we actually have, if you want to extend your applications, one of the great arguments for the cloud is, we have Azure Cognitive Services, which actually learns from different things, including language, speech, vision. You can do searches, and it actually tracks knowledge and gives you reliable commands as well, or reliable answers to questions with bots and things like that. But I'll show you an example of the vision for now. We created this thing called Bacon Not Bacon. I didn't actually. A colleague of mine created it, and it's fun. Kevin Bacon. So it actually. So let me give you a little background on this. Oh, man. Next. Oh, boy. Hold on. I agree. All right. I don't know what I just agreed to, but okay. Kevin Bacon. Let me explain what's going on here. So Silicon Valley has this show on HBO called Silicon Valley, and they built an app on this show. It's a comedy show that's supposed to detect all kinds of food, but they didn't have a budget to do all kinds of food, so they only did hot dogs. So it was a hot dog, not hot dog app. That's all it did. Is this a hot dog or not? So we thought it would be fun. We were sitting around at the office. It'd be fun to build a Bacon Not Bacon app. And not only does it detect actual bacon, but it detects Kevin Bacon. So just to show you that it does, it actually does view image. It's kind of fun. You can. So what you do with this is you put a URL in here, and it tells you, with some accuracy actually, yes, it's Kevin Bacon, but it's not actual bacon. But there is a picture I found that is actually both. Let's hope it's here. Yeah, there it is. There it is. Yeah, thanks. There it is. So this is a picture. We did not create this picture, but it's awesome because I could take this picture and it will. I just found this, by the way, just earlier this week. It will actually tell you it's both. So this is kind of a silly little demo but it's a cool app because what we had to do was set up cognitive services. We set up the Vision API, and we trained it with just 30 images. So we went out and got 30 images and said, this is bacon, this is bacon, this is bacon. And now it makes its own determination for us. And it runs all the time. It's on Azure websites. You can go check it out. Bacon Not Bacon, AzureWebsites.net. It's not always up because it's a demo app, but you can have fun with it. Play around. The more people try it, the better it'll be at detecting Kevin Bacon or bacon. So anyway, that's some of the things you can do with cognitive services. That's out on GitHub, by the way, the little piece of code that you use. Most of it is just the cognitive services on the back end. So. We have some resources here. I'll share the slides after. You guys can have a look at those. We have a dev center. We have some docs. And by the way, the docs, they're all on GitHub, and they're written in Markdown using Visual Studio Code. We allow you to go out, and I'm being prompted that we're getting done there. But let me go back to here. Yeah, so here's the step-by-step tutorials. Anything on our doc site, you can hit the edit button. It takes you to the GitHub image. You can file issues. You can send pull requests. You can do all kinds of stuff with that. So please do. It always makes us better. Also, if you have any specific questions, I wasn't kidding. We really want to get feedback about this stuff. Java@Microsoft.com. Or you can follow me on Benz. I'm also bbenz@Microsoft.com and everywhere else. GitHub, Stack Over, Reddit. And please do follow up with me, and we'll take some questions. I think we have a few minutes for questions. Yes? Right. So when you set up the Docker image, the idea is you've already got your Docker file created with... Yes. Okay, I get it. Yes, so when you create the Docker image, there's a couple things you can do. Create. Let's see. Sorry, web app. Where is it now? Web and mobile. Web app for containers. So when you create these... Let's just do that. Hopefully that's it's a taken one. I don't think so. There. All right. And I say configure container. There's always down here a startup file. So in that startup file, you would specify, it's a shell script. You set up your your environment variables. Yeah. Okay. And that works for the private registry and for the for all of them actually, except I don't think the Docker Hub one has it. But let me see. So that's a good question there. Yeah. For private access, you do. For not for the other, but for the private registries, you set up your image, your environment variables there. For the Docker Hub, I know there's a way to do it. I'm drawing a blank right now. Yeah, I know there's a way. What is it? Yeah, I'll have to. If you want to get back to me on that, I just can't remember right now. I know there is a way to do it. It's just a specialized way because it's coming from Docker, so the Docker file itself is already pre-made, and yeah, I don't know how to set up the environment variables. I'm drawing a blank there. Anyway, yeah, sorry. Any more questions? Okay, yeah, okay. I thought we had till 3:20. Okay, all right. Well, thanks, guys. And yeah, if you have any more questions, let me know. I'll be around. And I'm at the booth. We have a booth out there if you have any questions out there as well. So thank you.